This is the front of the study guide for Test 1 of Quarter 4 for Algebra B. So let's take a look at our first problem here. It's asking us to solve the system. So notice how the x's and y's are all lined up and the equal signs and the constants as well. So the best thing to do on this problem is just multiply one of them by a negative. So I'm going to go ahead and multiply the top equation by -1. And what that'll do is it'll make it a -1/2 x plus a 5y equals -30. So when I add this together, the x's will end up canceling because they're opposite in sign. So all I'm left with is a 12y equals -24. Careful on that subtraction there. So from this point, divide by 12, and we'll have the value of y. So y equals -2. So once I've got that, take that value of y and substitute it into one of those equations. I'm going to put it into that bottom equation, 1/2 x plus 7y. But in place of y, I'm putting -2. And then this all equals 6. So I go ahead and solve a little further, 1/2 x, and then this becomes a -14 equals 6. So I have to do some opposite operations there. So I'll go ahead and add that 6 to both, or add this 14 to both sides. And so what that leaves me with is this 1/2 x equals 20. Well, from that point, all I'm going to do is multiply by the reciprocal. Multiply by 2 on both sides, and that'll cancel out these 2's here, leaving me with x equals 40. So x is 40 when y is -2. So you'd write the answer as 40, -2. And this is where the 2 points end up, or the 2 lines end up crossing at this one point. Well, that's elimination. This is a good problem for substitution. Good for substitution because y is by itself. Whenever y or x is by itself, substitution makes sense. Difficult thing to remember is that this is double. Actually, it's the opposite of double y. So you got to put the 4x plus 1 in parentheses, set that equal to -3, and then go ahead and distribute that -2 over that addition. So we've got 6x minus an 8x minus 2 all equals -3. So we'll go ahead and do some work there. These two terms collect together and leave me with -2x. Well, go ahead and add that 2 to both sides right now, and this gives us -1. So when you do that division, you end up with a fraction. X is 1/2. Well, what you're going to do is take that 1/2, substitute it in for x. So let's rewrite our equation here. Y equals 4x, but in place of x, let's put 1/2 plus 1. So I just substituted, and 4 times by a half leaves me with 2. 2 plus 1 does make 3, so y equals 3, when x is 1/2. So there is our answer, 1/2, 3. Another good one for substitution, because you've got a variable by itself. So take that expression, put it in for y right there. Let's rewrite what we've got, 3x plus, but in place of y, let's put -3x plus 2, and this all equals 6. And so when we go ahead and do some work there, something interesting happens. You see, these cancel out. They make 0. They cancel out, so we're just left with 2 equals 6. So what we have here are parallel lines. Whenever your variables cancel out, all your variables are gone, and the numbers do not equal, we've got parallel lines. Well, a solution is where the lines cross. So here we have no intersection. And if there's no intersection, well, the solution's an intersection. That means there's no solution. So one way to show that is a 0 with a slash through it. Well, there is our answer. This next one, again, substitution makes sense. Take that expression, put it in for y right there. You got this 2x, and then you rewrite -2x plus 3, all equals 3. Well, we go ahead and do some work. We collect some like terms right here. These combine, but we get the same situation. This makes 0. 0 plus 3, well, that equals 3. So 3 equals 3. So what we have here is when we get those variables to cancel, but this time the numbers are the same, we have the same line. Well, if we have the same line, that means every point on the line is an answer. So we have infinitely many solutions, is what we say we have. Well, those are the first 4 problem. So let's take a look at this next one. It's a distance, rate, and time one. Distance between Los Angeles and New York is 3,000 miles. And so let's go ahead and write down distance equals rate times by time. A jet is flying from Los Angeles to New York with a tailwind. Okay, so we have a tailwind. And so whenever you've got a tailwind, that means the rate is actually increasing. It's faster than it otherwise would be. So we know we go 3,000 miles, but we go with the tailwind. So we've got the wind speed and the rate of the plane. So R is the rate of the plane, we'll say, plus W, because it's plus because of the tailwind. And how long did it take? With the tailwind, makes the trip in 5 hours. So put a 5 there. And it says on the return trip, we're against the wind, and then the jet takes 6 hours to make the same trip. So against means that we have that 3,000-mile trip, but this time against means we're subtracting the wind speed, and we go in 6 hours. So we could end up distributing that 6 and the 5 over. However, there might be a faster way. See, if you divide by 5, both sides by 5, so the 3,000 by 5 as well. This side, let's divide by 6. This will make the problem a little faster. Do that division, what you've got, 5 into 30 goes 600 times. So 600 equals R plus W. Over on this other side, 5 goes into 30 500 times, equals R minus W. Well, we can add those equations now. The W's will end up canceling. But watch what you have here. You got 1100 equals 2R, not just R. And so when you do that division, divide by 2, we end up with 550 miles per hour. And it says find the rate of the plane and wind. So let's go ahead and do that. So 550 miles an hour. Now to find the wind speed, let's just go ahead and plug this rate back into one of these. So just subtract this 550 from 600, and it will give us our wind speed. So 50 miles per hour is wind speed. So there it is. Next one, 2 cars leave town at the same time, going in the same direction. So it looks like this. Here's the town. One's going here, and one's probably going a little faster. And eventually, they're going to be 72 miles apart. So this is 72 miles. So let's call one of them D. That's the distance maybe this car went, the slower car. The other car went D plus 72, 72 extra miles. So let's go ahead and set this up. We have distance equals rate times time. Well, the rate is, for the slower cars, 30 miles an hour times by the time. Now, the time's the same, so we'll get to use the same time. The other equation is going to be D plus 72 equals 46t. And so we go ahead and use substitution here. It's the best method. Take that 30t and put it in for this d right here. So when we do that, we'll be able to solve in 2 steps. First step we're going to do is subtract that 30t from both sides. And when you do that, we still have 72, but now it equals 16t. Well, we go ahead and do some division. And I know 8 goes into these numbers, so I can divide them both by 8, and I get 9 over 2. So it looks like 4.5 hours is the time it takes. Now let's see if that's what they wanted. In how many hours will they be 72 miles apart? Yeah, that's what they wanted. Sometimes they might ask for how far were they from where they started. In this case, they didn't. So 4.5 hours is our time. Check part 2 for more for the last 3 problems.